When the material actually arrives from being shipped back from Greenland and you pull it out the boxes, it's fantastic, it's arrived in one piece. But at that point, you still don't know what you've actually brought back. A sediment core is something that we are collecting from lakes in Greenland. So it's an archive of what's happened in the lake in the past. We use a variety of things to tease apart this record. So we look at what the biological constituents of the sediment core. So we can look at that to determine how the environment has changed in the past. That's the first time anyone's ever seen these sediments, ever. So the first thing we want to do is photograph them before they change too much. Those observations are really important. We log the core. We observe any colour changes, any different changes in patterns, and how gradual or abrupt those patterns are within the core. Chironomids are an insect, and these are also called non-biting midges, and these are a two-winged fly, and these exist in the UK as well as in Greenland, throughout the world. Now these are a very important tool for us looking at climate, because the insects are everywhere. There's a large number of them in the environment, and that each species has a specific set of environmental conditions that it needs to thrive in. And one of the real main factors that determines whether this insect can live in a location is what the actual temperature is. Now, why we get them in the sediment core is that the adult insects lay their eggs within the actual lake waters, and the eggs then develop into larvae which live at the bottom of the lake. These larvae grow, shed their skins repeated times, and these skins are left at the bottom of the lake, and these get incorporated into the sediment. So when we come along and take a sediment core, within the sediment we're getting lots of these insects. The processing of chironomids from a sediment core takes a long time because of the microscope work that's involved. The actual sampling from the core, the sieving of the sediments, takes relatively little time. It's the actual picking of the heads of the insects out of the sediment water from under a low-powered microscope. So I have to pick out all the heads that exist in each sample, otherwise I introduce a bias. So I remove them from the sediment water and put them into a separate vial. And then to make sure that I can mount them properly on a microscope slide, I need to put the heads into increasing concentrations of alcohol, so to remove the water from the heads. So once I've done that, then I can mount them onto the glass slides. And I need to make sure that they have the right orientation, so that when I finally put the cover slip, so the extra bit of glass on top of the microscope slide, to press them flat, I need to make sure that they're in the right orientation so I can see all the really interesting parts, interesting features of each head, because that allows me to determine which is the species. And at that point, then I take the slide that I've made and put it under a high-powered microscope. And then I can look at it at a much higher resolution, higher magnification, and start identifying what the actual species are in each sample. This sort of work is, to me, really exciting because it gives us a real insight into our climate system. By being able to take these sediment cores and look at these sediments that nobody's ever seen before, these are unique, and we can tease apart records, a variety of records from one sediment core. So we can look at multiple different things that tell us different things about the climate, different aspects. And the ability to go back and essentially read this sediment like a book, so from cover to cover, so say from the top of the core to the bottom of the core, which might date from modern environments all the way back to 10,000 years in this case. By being able to do that, I think it's very exciting that we can see what's happened in the past. And of course that is very important, that we understand these systems for future climate change. Because if we don't understand how the systems worked in the past, then we're not going to be able to get to grips with what potential changes that might happen in the future.